Okay, so today's lesson is on power reduction formulas. So let me scoot to there. Yeah, this we already did. That we already did. So here we are, power reducing formulas. And I like to call this the superhero lesson because we're going to defeat the powers of our arch enemies. So we need all superheroes, and we're going to beat the villains today. You guys ready?
Yes.
All right, get your superhero gear on. Get out your lightsabers, whatever you need to fight off the enemy. All right. So here's our first victim. But actually, before we can, fight these superheroes, we need the proper tools. And so the proper tools, of course, are mathematical formulas, right? Because that's what we fight enemies with. So we're going to derive a formula for sine squared. We want to reduce the power of sine squared. And we're going to do that by using a formula that you already learned yesterday. And that formula was, let's just write this down. This would be cosine 2u is equal to, let's make this one 1 minus 2 sine squared u. Okay? We're going to choose that formula because I need a formula for rewriting sine squared. I want to reduce the power of sine squared. So all I'm going to do here is solve for sine squared. So I'm going to subtract 1 from both sides of the equation. That gives us cosine 2u minus 1, which equals negative 2 sine squared u. And then to finish solving for sine squared, we'll divide both sides by negative 2. There we go. And so now we have a formula for what sine squared u is equal to. And I'm going to do one last little thing. I'm going to multiply the numerator and denominator by negative 1, and then I'm going to write the formula over here to the side. I'm multiplying by negative 1 over negative 1 just because I want to make it a little simpler, more cleaner looking. So we'll make this 1 minus cosine 2u all over 2. That's sine squared. So if we use this formula, we could rewrite an expression, sine squared, as cosine. It involves cosine to the first power as opposed to sine to the second power. So we reduce the power on the sine function. So that's why we call it the power reducing or power reduction formula. And that's why I like to kind of tie it in with superheroes, because that's what superheroes do. They like zap the power of the evil villains. All right, so notice the power reduces by 1. What happens to the angle measure? The angle doubles, right? The angle doubles. So that we want to kind of keep that in mind. All right, so let's come up with another formula, this time for cosine squared. So for this one, I'm going to start off with this version of cosine 2u. Which one am I going to start with? Did someone start to say it? I thought. Maybe not. All right, so we're going to start with 2 cosine squared u minus 1, because that's what equals cosine 2u that we learned yesterday, the double angle formula. So now we're going to rewrite that. We're just going to solve for cosine squared. So add 1 to both sides of the equation. So now we have cosine 2u plus 1 equals 2 cosine squared u. And then dividing both sides by 2 solves for cosine squared. And then I'm going to write that over here to the side as well. So now we have cosine squared u equals, I'm just going to flip the order of that numerator just so it kind of looks more like the sine squared formula. And it'll be a little easier to memorize this way. So I have 1 plus cosine 2u over 2. So it's really very similar formula, okay? This one is 1 minus cosine 2u over 2. This one is 1 plus cosine 2u over 2. And in both cases, the power of the trig function gets reduced by 1, and the angle gets doubled, okay? And then finally, tangent squared, that's kind of easy to derive. We can actually pull that right from these two, because we know that tangent squared equals sine squared u over cosine squared u. So we can write 1 minus cosine 2u over 2, and then divide that by 1 plus cosine 2u over 2. The 2's divide out, and then we have our formula for tangent squared. Okay? And if you kind of peek down at your page, down the middle of the page, you'll see all these formulas summarized. Okay? So I'm going to clear this. So there we have it. There's our 3 new formulas. And these are going to be our formulas for battling the superpowers. Okay? So our first victim here is going to be cosine to the 4th. This is where you might want to switch over to your homework page, because you can just do the work right there. And when you finish today's lesson, you'll be 1/3 done with homework, right? Because 2 out of 6 is 1/3. Okay, so I'm just going to zoom in a little bit here so I have a lot of space to work. So my first villain is cosine to the 4th. So we want to employ our superpowers, and we're going to write this as cosine squared times cosine squared, only because we have a power reduction formula that we can use for cosine squared, but not a power reduction. I don't have one for cosine of the 4th. I just have a power reduction for cosine squared. All right, so let's make the substitution. We just, someone ringing? Is that me? Oh, wow. Okay. That's a very strange alarm. It's not like the alarm. All right, so now it's strange. Oh, there we go. Huh. How did I get a ringtone like that? All right, anyway. Back to our lecture. All right, so cosine squared, we're going to replace this with 1 plus cosine. The power goes down by 1, but what happens to the angle? Doubles, right? So now that's going to be cosine 2x over 2, and then another 1 plus cosine 2x over 2. And now the end result, what we're looking for is, I want to rewrite this cosine to the 4th, so it will be the sum of a bunch of trig functions. It could be sine x's and cosine x's, or sine 2x and cosine 2x. But I want it to be just a sum of a bunch of trig functions without any multiplication involved, except for maybe where I factor out the denominator. Okay, so that's our goal. That's where we're heading. And it's going to look like we're not simplifying, because bless you. We're not simplifying because we're really not simplifying. We're rewriting this in a form that will be more convenient for you when you take calculus and we do some integration. And the only reason this kind of fits in this chapter is because this power reduction formula derives exactly from the double angle formulas. So they throw that in at this point. So it feels a little like we're getting a curveball here, and we kind of are. Okay, it's kind of a little curveball. All right, so let's do this. Let's multiply these together. And this is like a formulaic way of rewriting this expression. There's unfortunately no like original or creative thinking in this lesson. It's all kind of like follow the formula, which sometimes is kind of a nice little break. You get a little breather, but because you've been doing a lot of original thinking with solving equations. So now it's kind of like formulaic. So we'll just sort of follow the pattern. And the pattern here is we're going to multiply these back together. I'm going to use FOIL. So I'm going to multiply 1 times 1, and then 1 times cosine 2x. And then I'm going to multiply cosine 2x times 1. And then I'm going to multiply cosine 2x times cosine 2x. And then it all gets divided by 4. Okay, part of the end result of our problem here is we want to make sure that we don't want a denominator. Okay, we want to just have nice little individual terms without a denominator. So in my next step, I'm going to factor out the 4, which really means just factoring out a 1/4 from that whole fraction. So I'm going to write this as 1/4 times the numerator, 1 plus cosine of So long as I'm writing these cosines, I might as well add them together, right? The cosine 2x plus the cosine 2x. So I will add these together and get 2 cosine 2x. And then, now I have this pesky little cosine squared again. Now I want to reduce the power, right? That's like the enemy. We're going to bring out our superpowers. So what do we replace cosine squared 2x with? Well, we use the formula again. So we have 1 plus cosine of, now what angle should I write there? Reduce the power, but what do I do to the angle, Ethan?
Increase it?
Yeah, yeah, do by what, Dylan? Yeah, make it 4x, good. So we're just gonna double the angle. So the power goes down by 1, but the angle gets doubled. So I already doubled this angle once when I applied the power reduction formula. Now I'm gonna double this angle again, so this is gonna be cosine 4x, and this is all over 2. And now, just this part of my expression has the denominator. These two terms in the front, they don't have the denominator, so if I want to factor that out, I need to make sure that all the terms have that same denominator. So I'm going to do this. I'm going to just multiply, I'll just kind of sneak this in here. I'm going to multiply by 2 over 2, and I'm going to multiply here by 2 over 2. So now everything has a common denominator, and I can just factor out that 2. So that 2 is going to come out in front as a 1/2. I already have a 1/4 out front that I factored. And now 2 times 1 here is just 2. 2 times 2 cosine 2x is 4 cosine 2x. This already had the denominator of 2, so I just leave that alone. So I have 1 plus cosine 4x. All right, so does anyone have trouble seeing what I did there? Common denominator first. Factor out a common factor of 1/2 from every term. And now we can just kind of clean up our answer, all right? And I like to use another color, like a superhero color. What superhero would you like? Green. What superhero would that be? The Green Lantern. Yes, I like the Green Lantern too. Okay, so our finished product, when we've reduced the power of this cosine of the 4th, is going to be 1/8. And now it looks like I do have like terms here. I can add the 2 and the 1 together. So I get 3 plus 4 cosine 2x plus cosine 4x. Okay? And don't be worried that the angles are now different. That's all okay. Our goal here is to write everything as a sum of trig and algebra expressions, really trig and numbers, and then factor out that denominator. So then we're all done. That's what we're looking for right there. Okay, are there any of the steps that you guys lost, that I lost you on? All right, let's try another problem. Let's try sine to the 4th. So now sine to the 4th, we're going to write that as sine squared x times sine squared x. And now we have a power reduction formula for that. Look on your sheet and make sure you have the right formula. Tell me what I should write here for sine squared. 1 minus? Okay, so the formula for sine squared is 1 minus cosine 2x over 2. Again, I reduce the power, but I think I double the angle. Okay, reduce the power, double the angle. And I can do the same thing for this sine squared. That's going to be 1 minus, oh wow. Did you see what wacky thing happened? My board got that goofy line again. I'm going to have to redo this. 1 second. Okay, try this again. 1 minus cosine 2x over 2. 1 minus cosine 2x over 2. And now, like I told you a few minutes ago, this is like a real sort of formulaic process. You do the same thing over and over. So my next step is to FOIL. So we do 1 times 1, 1 times negative cosine 2x, negative cosine 2x times 1, and then finally negative cosine 2x times negative cosine 2x. That gives me cosine squared 2x all over 4. And once again, in the process of doing that multiplication, I've generated another trig function with second degree. So we're going to reduce that in a moment. But I'm first going to factor out the 1/4, just like we did before. Combine the like terms, so I have 1 minus 2 cosine 2x plus, now we're replacing the cosine squared. So now turn back your page and see what your formula should be, if you don't remember it. It's going to be, somebody help me out, 1 plus what? Okay, and in this case, we're reducing cosine squared 2x, so what am I going to do with the angle? Double it. So now it's 1 plus cosine 4x over 2. All right, and then again, just like this problem, I want to factor out that John.
Why can't we just factor
So if you factor the numerator, you're back here where we started from. Okay, we're just trying to like rewrite it in a new form. Okay, so let's multiply by 2 over 2 again to get a common denominator. Multiply by 2 over 2 here to get a common denominator. And then when I factor out that denominator, I'm going to have a 1/4 times a 1/2 in the front. And then I'm going to have 2 minus 2 cosine 2x plus 1 plus cosine 4x. And then finally, what superhero shall we use now? Which one? Batman? Okay, Batman would be black, of course. All right. So we have 1/4 times 1/2 is 1/8. And then we have to add the 2 and the 1 to get 3 minus 2 cosine 2x plus cosine 4x. All right. So, questions? Ethan.
I understand they have to get the common denominator, but were you getting 1/2?
The 1/2 is what happened when I factored out the common denominator. So I found a common factor of 1/2 in each of these terms, and I factored it out front, and then I just left the numerator in the parentheses.
Okay.
It's like this. What if I had,
Wait, I think
if I have 1/2 a minus 2 halves b plus c over 2. You see how I could factor out a common factor of 1/2 in each of those? So this would be like 1/2 a minus 2b plus c. I factored out a common factor of 1/2. So that's what I did here. Here's the denominator, here's a denominator, here's a denominator. Every single term in that expression has the denominator too, but it's factored out. Michael? Where did I? Oh, gotcha. Oh, thank you very much. Yep, right back here. I want to change. Yep, thank you. I missed that. All right. So this is going to be a minus 4 cosine, and this is going to be a 3 minus 4. Awesome. Okay. Angela, was that your question before?
No. I'm just wondering, like, in general, if it were, like, in the second step, if it were, like, cosine squared 3x, would it turn into 1 plus cosine 6x over 2?
Yes, perfect. And there's some problems like that. Let's see, if we look at your homework assignment. So problem 3 is just sine squared, cosine squared. So you're going to substitute in the identity for sine squared. And then you're going to do the other identity for cosine squared. And then problem 4, there's where you have a 3x. So when you use the identity there, that angle is going to become a 6x. Okay? And if you have to apply the power reduction formula again, then it's going to become 12x. You know, you just keep doubling the angle. Okay? Any other questions? This is like rather routine, but it actually will be super helpful next year when you take calculus and you try to integrate some really messy looking trig functions. So it will be helpful at that point. And like I said, it kind of gets thrown in here just because of the identities that derive right from the double angle identities. All right, you guys have about 10 minutes. You might be able to get those 4 problems finished. And then WebAssign tonight, okay? If you can just carve out a little time for WebAssign, that would be fabulous.